Here we are on page 2 of correlation and regression. Um, at the top here, the reading tells us um, that we are going to draw what we call the line of best fit by eye, which means we're going to eyeball it, or we're not going to really use the calculator's function to help us do that. Okay, and this is the way that before graphing calculators and computers, it was very common for students and scientists to do this method using graph paper and a pencil to find out the trend for their data. And when you do that, basically you have a cloud of points here, a bunch of points, and you're going to draw a line through it. One point which you could figure out with even a scientific calculator from a million years ago, you could figure out the mean point, which is like you would find the average of all the x's and the average of all the y's, and that would be kind of the middle point of the cloud, and then maybe it would be right here. And then you would determine that the line did go through that point. And then, like, to see how slanted the line is, you would just kind of eyeball it. And then you would draw it with your pencil and a ruler. So its first step is to find the mean, and then you just plot that mean, and then you try to draw the point through it. And you try to draw the line in such a way that there's an equal number of points to the left and to the right of the line, or to the above and below the line. And you need to keep in mind that depending on what you're doing, the line does not necessarily go through the origin or through the point where the x-axis intersects with the y-axis. So don't be worried if it hits the y-axis or if it hits the x-axis. Normally with data, that's going to happen, and usually there's a meaning to that. Okay. Just like in our investigation with the bowling alley prices, it hits the y-axis at a non-zero point because even if you have 0 players, the party costs you the initial fee. So it crosses the y-axis at the initial fee, for example. Okay, so for exercise 5E1, what we're going to do is we're going to take data distributions and we're going to plot them on the scatter diagram, and then we're going to say what type of correlation it is, and then we're going to find the mean of the x and the mean of the y to help us draw a line of best fit with a ruler. Okay, and of course I'm not going to do it with a ruler here, but you're going to use a ruler on your paper. Okay, so the first thing I'm going to do is I'm going to plot these points just like I did on the other page. Okay, and in this case I am going to do just one of these, but the other one's exactly the same. It's just for time considerations, I'm not going to do both. Okay, so let's choose. Let's see. I'm going to do this first one, 1A. Okay, so I'm going to start plotting the points here. 2, 14 would be about there, and 4, 15 would be about there, and then 6, 18 would be about there, and 8, 21 is about there, and 10, 24 is about there, 12, 25 is about there, 14, 27 is about there, and 16, 29 is about there, 18, 30 is about there, 20, 32 is about there, 22, 35, 22, 35 looks like it's about there, and 24, 39 looks like maybe there. Okay, so that looks pretty linear there. So I would say that the type of correlation here would be positive because it's going in a positive gradient direction. It's linear, and I would say it's at least moderate. It might be strong even. So strong or moderate, strong or moderate. And then and now I want to plot the mean point. And to plot the mean point, now this is the part that's going to take a long time here because to put things in this calculator, online calculator, is a real slow process. Okay, so what I'm going to do is I'm going to clear out my L1 and L2 columns, and then I'm going to use these L1 and L2 columns to load up this data. So the L1s, I'm going to put the X's in, and the L2s, I'm going to put the Y's in. And for example, 2, comma 4, and you see I'm just going across the X's here, 2, 4, 6. And then in the Y's, I'm going to do the same thing, except I'm going to put 14, comma 15, comma 18, 14, comma 15, comma 18. All right, and I'm just going to put all these in, and I'm not going to make you watch me do this boring process. I'm going to finish this, and you do it on your calculator, and we'll be back up in 2. Okay, so I just finished inputting all the X's and all the Y's for 1A, and once you get all the data in there, then you're going to find X bar and Y bar, or the mean of X and the mean of Y. And the way you do that is with stat calc, and we've always used stat calc 1 var stats. Now for the first time we're going to use stat calc 2 var stats, and the reason why we're using 2 var stats is for 1 var stats we've used L1 and L2, and L2 has always been the frequency list. It just tells you how many times the data in L1 occurred. In this case, our Y is not the frequency list, or L2 is not the frequency list. It is another data point. So it's, list 1 is data. List 2 is also data, okay, that occurred together. So we're going to use 2 var stats, and we're going to specify that the X list is L1 and the Y list is L2. And then we go down to calculate, and then we're going to find out what the mean is for not only X bar like we did for 1 var stats, but also Y bar. So X bar looks like the mean is 13. And Y bar, if we go down a little bit, we're going to see what the mean is for Y bar. There it is, 25.75. 25.75 is the Y bar mean. And so if we plot the point 13 comma 25.75, and I'll do that with a different color so that you can see it, we'll see that 25 comma 15.75. 25. Oh no, it's 13 comma. I thought that was weird. 13 comma. That color is too close to red. Okay, so 13 comma 25.75 would be about there. So it's about there. Okay, so there's our mean point, X bar and Y bar. So the answer to 2 is these points right here, and then we plotted the point. It says plot the mean point, okay, and then it says draw the line of best fit. So when you draw the line of best fit, you should use a ruler, and here I'm not going to because I haven't figured out how to use a ruler on this program. But you're going to use a ruler on the exam and on your homework, and you're going to draw a straight line, wow, that's pretty good, through that green point with approximately the same number of red points to the left and to the right of the line, or above and below the line. So that is your line of best fit drawn with eyeballing, or with your eye. Okay, so for the other one, it's the same thing. The other set of data here, you just do the same plotting, and then you put it in L1 and L2, and then you run stat calc 2 var stats to get your X bar and Y bar. Okay? All right, let's move on to the last question on this page. So this one, the only difference is that the numbers are just, radically different. The Y values are in the hundreds and thousands, and the X values are small numbers from 4 to 6. Okay, but otherwise we're just going to do the exact same thing. And then we're going to go one step further. You can see that at the very end it asks us to use the diagram to calculate the weight of a giraffe of a certain height. Okay, so let's try that. Okay. So first we're just going to plot all these points. And the first point we're going to plot is 4.8 comma 900. Oh, we need to mark our axes here. So we're basically plotting points here between 4.1 and 5.5. And then for the y-axis, we're plotting between 650 and about 1,250. Okay. So let's mark our axes here. And so for the x-axis, I'm going to just start at 4.0. And we're basically going to go up to 6.0. So we'll do 4.0, 4.2, 4.4, 4.6, 4.8, 5.0, 5.2, 5.4, 5.6, 5.8, 6.0. Okay? All right. And on the y-axis, we'll start at 600. And then we're going to go up to about 1250. So I think we can, let's try this. We'll jump by 4 units, and we'll jump by hundreds. Is that going to work? 600, 700, 800, 900, 1,000. It's going to get kind of close. So I had to jump by 2s, so each one of these is worth 50. So 600, 700, 800, 900, 1,000, 1,100. Okay. Plot the points on the scatter diagram, describe the correlation. Okay, so let's plot the points first. So the first point we're going to plot is 4.8900. 4.8900. 4.1 600. 4.1 600. I'm going to use a different color because maybe I'll just use this kind of pen. There's one. Oops. There's one. There's one. 4.1 600. Yeah. And 4.2 650. 4.2 650. 4.7 750. 4.7 750. 5.0 1100. 5.0 950. 4.8 850. 5.2 1150. 5.2 1150. 5.3 1100. Hey, I see I did something wrong with 12. Did you see that? My 1200 is a little bit high. Okay. So that is also wrong. I want to put last 5.2 1150. 4.8. 5.2 1150 would be right there. No. 5.2 1150 would be right there. 5.3 1100 would be right there. 4.3 650. 4.3 650. And 5.5 1250. 5.5 1250. And 4.5 800. 4.5 800. Okay. So that looks pretty linear. I would say it's positive, linear, maybe moderate. Okay, maybe strong, but looks maybe more moderate. Find the mean height and the mean weight. Okay, so to do that, we need the calculator. And we're going to put that into StatEdit. And just so that we don't erase our old data, we'll put it in L3 and L4. Okay, and we just put it in the same way we did before. We're going to put 4.8, 4.1, 4.8, Oops, it's putting it, look, I'm in fraction mode, so I can go to mode and I can change that to decimal mode so that it doesn't look so weird. Here we go, mode, answers in decimal. And then we'll go to stat, edit. So now, instead of 24 divided by 25, we're going to want to put in 4.8. Okay, and then we'll put 4.1, etc. And then in the Y column, or the L4, we're going to put 900 and 600. And I am not going to make you watch me input all these numbers. I want you to input them in your own calculator for practice. So I'm going to meet back up with you in 2 seconds with all our calculators filled in. Okay, so I finally finished putting all this data here into L3 and L4. So you can, let's go to the bottom line just so you can see that it's all done. The last point is 4.5, 800, 4.5, 800. So now we're going to find the mean height and mean weight. So the mean x and the mean y. Remember, the way to do that was we do stat calc, and we do 2 var stats instead of what we've always used, 1 var stat. And for the x list, we tell it, oh, this time we used L3, not L1. And this time we used L4, not L2. So we put those in, and then we do calculate. And then it's going to give us the x bar and the y bar we need. So the x bar is 4.78. I'll remember, always get 3 significant figures. 4.78 x bar. Y bar is 896. 896. Okay? 4.78 and 896. So, let's mark that. 4.78 is about here. Oops, no, it's not. It's right about here. And 896 is about there. So the point is about there, the mean point. Okay? And then we are going to draw the best fit line, which is going to go through that orange point, and it's going to be straight, and it's going to be kind of right through the middle of the cloud with the same number of points above as below. And I'm going to draw it without a ruler, because with this program I can't draw a straight line exactly, but when you do it on your paper you're going to use a ruler. Okay, that's pretty good. And now we're going to use the diagram and my line to estimate the weight of a giraffe of height 4.6. So let's say, where is 4.6? 4.6 is right there. And that's kind of an unfortunate color. It's too much like the other ones. 4.6 is there. So 4.6, how much does that giraffe weigh? About 800. So I'm going to guess 800 kilograms for a 4.6 meter giraffe. Okay, because the relationship between the height and the weight of the giraffe is almost a line. So we can predict the weight of a giraffe that we've never seen before. Isn't that useful? That's the end of page 2.